Hey everybody, my name is Charbel Marche and I'm excited to tell you all today about the research I've been conducting over the past 3 months. I've been applying artificial intelligence and machine learning techniques into the fields of emergency and trauma medicine. So let's dive in. Before I start, I want to give a big shout out and a thank you to the PI on this project, Dr. Harka. I appreciate everything I was able to learn from you over the past few months. So let's start with some background. When trauma patients show up to the hospital, they receive ICD codes that correlate to the injuries that they've sustained. These codes are useful for billing, but they aren't so great for research and informational purposes. AIS codes are developed by the American Association for the Advancement of Automotive Medicine, or the AAAM. AIS codes, which the format of I won't dive into, are much more useful for research and contain information on the level, the location, the severity of the trauma, and the different organs affected. There are vast databases that include ICD codes given for trauma patients, which would be very useful for research if only those ICD codes could be translated into AIS codes. So how is this currently done? Currently, the industry standard is an ICD map. This is provided by the AAAM itself, and it maps ICD codes to AIS codes. You would think the problem is solved, but it's not. While the map is useful, it's not perfect, and let's take a look at how it does. So using real-world data of patients who receive both ICD codes and AIS codes for sustained injuries, we can see that the map is far from perfect. It only gets exact matches 0.3% of the time, and what this means is it only guessed the correct AIS codes that were actually given 0.3% of the time, given the ICD codes that were given for that patient. It gets a close code to the real-world AIS code about 75% of the time, and the rest of its results were not ideal. So how did we try to get better results? What we did is we used different machine learning tools to try and beat the ICD. So the different tools that we used are OpenNMT, which is an open source tool for neural machine translation, SMT techniques, which is statistical machine translation, which uses statistics to map one language to another, and a feed-forward neural net, which is built using PyTorch. This machine learning technique uses an architecture similar to the neurons in your brain to learn and predict. So after we went and implemented these different techniques, built the feed-forward neural net, fine-tuned everything to try and get optimal results, let's take a look at how they stacked up. So the best results that we found were with the feed-forward neural net. It found exact AIS code matches 66% of the time, and was close to finding exact matches 17% of the time. It was only far off around 10% of the time. Where this technique could be improved is with unmatched predictions. So 30% of the predictions that this feed-forward neural net made were over predictions. And what this means is that codes that the neural net predicted weren't correlatable to any real AIS code that was given. OpenNMT was the next best. It had less exact matches and more close and far off guesses, but it had far less unmatched predictions than the neural net. SMT was the third best, and you can see the results on the screen. It was just a little bit worse in every category, but it didn't have the same amount of unmatched predictions or unmatched observations as the other two. And at the top right, you can see the ICD map results just for reference. Note that all three of these techniques beat out the ICD map itself. So now that we have these results, you might be wondering what's next for this project, and that's a fair question. So what's next is we're going to meet with a CS professor that's also on this project and try to improve the feed-forward neural network and decrease the number of over-predictions that it's making. I've been working on a project website as well that will talk about what we've done, host some of the code, and share some of the code publicly so that other people can recreate the work that we've done. And hopefully at the end of all this, we are looking to write a paper on the findings and then use the tool that we've created to conduct more research in the field. And that's all I have for you. So thank you so much for giving me your time. I look forward to receiving any questions or feedback that you might have to give. Don't hesitate to reach out. My information's on the screen. Have a great day, guys.